Hello my dear students, this is Akash SD and welcome to the ASD physics classes. Hope so, doing good. Let's start learning gravitational potential energy basic concept. Okay. So students, here the first thing is what we are going to see, gravitational potential energy. Is it? Potential energy you have studied very well, but now we will see from the very basic point of view. So let's see, gravitational potential energy of a system, two particles or three particles, is defined as the amount of work done by external force to make that system without changing kinetic energy. And later I will teach you why gravitational potential energy of an isolated particle is always zero. In the lecture you will understand very well why I am telling like this. Next one, first we are going to learn a relation between potential energy and potential difference. That is very important. Okay. So students, what is here? Here I have taken one mass, capital M, and you know that gravitational field due to this mass is what? Towards the mass M. Okay. After that, what I am taking here? Here I have taken the 2 points here. This is point A and this is point B. Now one mass small m I am taking from point A to point B without changing the kinetic energy. So here the concept is what? Potential difference between point A and B. B is the final point, A is the initial point, is defined as work done by external force to move the mass from A to B by M. Okay, and we can tell here in this situation work done by the external force A to B is equal to M VB minus VA. After that, students, if in case the kinetic energy is not changing, then this work will increase the potential energy, and we can tell here this delta U is equal to M into delta V. This is the relation between potential energy and potential difference. Again, I am telling delta U equal to M into delta V. Please remember that here. Okay, this thing is the separate here. Now after that, we are going to see this one, gravitational potential of a system of two particles here. Okay, so here what I have taken here, I have taken this one mass M1 and one mass M2 will be there. Okay, and they are separated by how much distance? R12 distance is there. Okay, so what will happen that here I am going to take these masses from infinity to make the system here. Here I have taken one mass M1, this mass M2, but these masses are coming from where? From the infinity. Okay, so let's take here please. Here infinity is there, and at this point mass M1 is there. Somewhere other place also very far distance M2 is there, and again we have to take the mass from where? From infinity to make the system here. Let's take, I have taken this is point A and this is I have taken point B. Understand it very well, students. So as the kinetic energy is the constant, so we can tell delta U is equal to work done by external force from infinity to make the system. Delta U means potential energy of the system minus potential energy at infinity is equal to, now what will happen that when first mass will come from infinity to point A, in that situation there is no gravitational field because there is no initial mass, only the first mass is coming, and first mass is coming in the absence of any gravitational field. That means what will happen that when the first mass will come from infinity to point A, in that situation there will not be any work done. Now, as I am telling, before that there is the no mass. That's why no work done to take the mass from infinity to point A. After that, what will happen that here, this second mass will enter into the gravitational field of which mass? First mass. So we can write here, now work done by the external force from infinity to point B. Which work done? External. So what I am telling that, again listen please, the second mass is entering into the gravitational field of first mass here. So here to calculate the work done, what we have to do, mass and here potential difference concept. Potential at point B due to A, is it? Like this. Okay, so what will happen that here? 0 plus, and here how much here? M2, and this one will come here minus G M1 by R12. Hence we can tell here U minus U infinity is equal to minus G M1 M2 by R12, is it? And this I am considering potential energy at infinity how much? 0, is it? That means our formula is coming U equal to minus G M1 M2 by R12. Okay, remember that here. Again I am telling, listen one more time. First mass, when it is coming, there is no gravitational field. Okay, second mass is coming into the gravitational field of first mass. Now in next class we are going to see Now, special case here. So here what is happening that here, let's take here students. Here again I have taken the masses. This is M, this is M, and this is the first case here, now separated by distance R. So here potential energy is given by minus gm square by R. Very easy. Okay. After that, what will happen that here sometimes here this earth is there, now, and at the surface of the earth one mass small m is there and here capital M is there. So in this situation, what is the gravitational potential energy of the system? The total mass of the earth can be concentrated at the center and small m is here, and this one is how much distance? This is the radius of the earth, students, here, is it? So in the second situation, what is the potential energy? See please, minus g capital M small m by R. Okay. After that, next one please see here, GPE of a system of 3 particles. Here what will happen that here, again very basic thing here, this one I have taken A, B, C, and the masses are here. Let's take for example, this is M1 here, here M2, and here M3. This distance is R12, this distance is R23, and this distance how much? R31. So here also students we have to use the same basic. What is the basic here? See please here, as delta U is equal to work done by the external force to take mass M1 from infinity to A, is it? So here please here, there is U minus U infinity. So now again I am telling, when the first mass will come from infinity to A, no work done will be there. Similarly, work done by the external force to take mass from infinity to point B. Now the second mass is entering into the gravitational field of first mass. So we can write here 0 plus M2, and here we will write here VBA. Now potential due to only one mass, plus after that students again work done by the external force to take mass from infinity to point C. Now what will happen? This third mass will enter into the gravitational field of two masses. So we can tell here plus M3 potential at point C due to A plus potential at point C due to B here. Now, so again we'll write here U, this will become here students 0. So U minus 0 equal to M2, and here minus G M1 by R12, again plus M3 here, what to write here? Minus G M1 by, what to write here? R31, and one more thing, plus M3 minus G due to this M2 at point 3 minus G M2 by R23. Okay, so you have to just simplify this, you will just get it here. Okay, very easy. Similarly, if we are telling fourth mass is coming, so it will enter into the gravitational field of 3 masses, and in that situation how many pairs will come? Total 6 terms will come. So for that we have to remember the formula. If n masses are there, so number of pairs is given by n minus 1 by 2. Remember that here. Now whenever it comes to the gravitational potential energy, we have to see the number of pairs to simplify all these things. Okay, next one, see special case students here. So see here please, here I have taken R, here mass M, mass M, mass M. So here can you see how many pairs are there? 3 pairs are there. Even you can use this formula also, n minus 1 by 2 also for the number of pairs, and potential energy will come what here? For 1 minus gm square by R, we have to just multiply with the 3, very easy. Now similarly, if we see this one here students, see square is there, M, and here also M. This is the, I am taking the first case here. Now in case of second situation, again R, and R. Here how many pairs are there students? Again you use the formula n minus 1 by 2, just put n equal to 4, you will get 6. So what will happen? 4 pairs will be sidewise, 1, 2, 3, 4. Okay, so 4 pairs sidewise means minus g m square by R into 4. After that thing please, 2 pairs will be diagonal wise here. Now see this one here, this one here. This distance R root 2, this distance also how much? R root 2. And how many pairs students? 2 pairs. So see here please, minus g m square by R root 2 into 2, and you just simplify this and you will get it here. Okay, now the last topic. Remember what I told you students here, for isolated system there is no potential energy. It is always defined for what? Pair of masses. So here please, here very easy. Gravitational potential energy of an isolated particle is always 0, because there is no work done by gravitational force to take first particle from infinity to make the system of a single particle. Okay students, so with this we have just reached to the end. Thank you so much.